We are thrilled and honored to be selected by the Department of Energy and Argonne National Labs for a chance to satisfy the Coral mission. The Coral announcement represents an exciting beginning of a new future for high-performance computing for basic science, engineering, and other forms of digital simulation and analysis research. The reason Coral is so important is it attracts a community of researchers and scientists in using a set of tools that have never really been available before, depending on what their science needs, whether it's data-intensive computing, whether it's balanced computing between memory-bound, highly memory-intensive, or computational-bound applications. All of those things getting served in a machine at that scale is like having a science platform, a research platform that this community has never had before. I'm actually less excited in some sense about the machine itself and much more excited about what the machine can enable and looking forward to the world it creates as opposed to the world it will live in. In order to build a system of this scale with advanced compute, with advanced memory, with advanced interconnect, and advanced software, a lot of which the world has never seen before, required collaboration not only between the functional pieces of the system, the hardware and the software, but all of the folks that are going to then make use of those things. It took unprecedented level of collaboration to understand what these interlocking and interdependent portions of the system would need to do to then not only build them and design them, but make sure on the back end that they actually worked as designed and met the needs of Argonne and its science community. What the Aurora system does is provide a way for system capability to be designed and optimized for different ways of using it, from traditional classical simulation and modeling to extremely data sensitive and data-driven decision science applications, and everything in between. So when we look at the system architecture that is such a multi-role and has the ability to scale from this class of a high-end system to the same technologies and innovations being used on personal supercomputers, it is indeed almost impossible to predict how far and wide its impact can go. It is no longer 1 or 2 or 4 applications have to run well. It changes the paradigm from supercomputing being a tool for a specific problem to supercomputing being a general tool for many. And that's creating that infrastructure is exciting. It comes at a time when the innovations, when the value of those innovations and the challenges to innovations like energy efficiency, like resiliency, are orders of magnitude more important than they've ever been before. So if you're a chip designer, if you're a systems designer in packaging and power packaging and cooling, or you're a software writer, everything you did 10 years ago, today, and Coral is not 10 times more difficult, it's 1,000,000 times more difficult. And if that doesn't excite you, I don't know what would. If we can solve the problems of energy efficiency and some of the other challenges relating to realizing that kind of a system within those power budgets, we will have a petaflop system in what's a rack under your desk. Just imagine the new markets that can be opened up when supercomputing is democratized at that scale. Coral is not a destination for us at Intel. Coral is one very important step in a journey that's much longer for us. What we are looking at, and we've done through the history of our participation on the infrastructure and data center side, is bring innovations in silicon, architecture, and software to the market and democratize it. We've had Tera, then Peta, the next North Star at exascale, and trust me, by the time we've all figured out how to solve and reach exascale, we will be worrying about zeta and yotta scale computing. So it's one more landmark, it's the next one we have to reach, but the journey doesn't stop there.